Hello and welcome to session 269 in the AISafety.com reading group. Tonight we'll be discussing the article Hard Problem of Corrigibility by Eliezer Yudkowsky. Eliezer Yudkowsky is the chief researcher at MIRI and one of them, probably the founder of the modern field of AI safety. This is an article on Arbitel, an abortive attempt to make a new platform for these kind of articles. And it's very old, from 2016. So this is in fact a very different article from the ones we normally read. For one, it is very short, 3 pages, and the shortness may in fact be a big part of the appeal of the concept of the hard problem of corrigibility, that is something that can be expressed in relatively few words. When we chose this, I predicted that I could probably contribute very little to this, and there was a higher than normal probability that I would misunderstand something on a conceptual level. So please be aware that there may be errors here. But one of the reasons why I think it's much more interesting now than it was back in 2016 is the emergence of large language models, which seem to be able to handle these kind of less formalizable concepts much better than what we expected to have back in 2016, or what I expected to have back then. I introduced this and I talked the other people into accepting this article with the claim that if I had to come up with a solution for alignment, like literally right now, what would I do? And I think I would work on the hard problem of corrigibility. And I think the timelines are in fact getting short for a lot of people, and some of the more ambitious solutions may just be out of time. So this seems like an interesting Hail Mary idea. So let's talk about define the hard problem of corrigibility. And there is a reasonably crisp definition of this. What we want to do is to build an AI that's an agent that reasons internally as if from the programmer's external perspective. So that means from our as programmer, our external perspective is that the AI is incomplete. We haven't put our total values in it, and there's probably many things missing. When we have designed it and implemented it, we have made mistakes. We would like to correct the AI. We want to correct our mistakes, and we believe that the AI is dangerous. We believe that the AI is going to do weird things, and that is kind of actually the point. It has to do weird things. That's why we have it. And that means that it is important that the AI asks us, and it cannot, even if it calculates that this is what we want, then that is in fact not what we should do, what it should do. And so the idea is that this external perspective that we have is one that the AI should internalize somehow. So I could try to make this even more crisp by making this the following statement: that the AI should believe that it contains an epistemic bug that makes it assign too high utility to not being corrigible, to not allowing the programmers to change it. So that is what we want the AI to believe. And then the question is that actually true? And that is in fact one of the more thorny philosophical questions, because to some extent it is true, and it may even be that it is not true, that there is in fact no such bug, but we still want it to be corrigible even in the absence of such bugs. And then we want the AI to believe this false thing. Corrigibility is very anti-natural, in the sense that if we go back to the standard problem of corrigibility, we have an AI which maximizes a utility function, and then if we try to change it to maximize a different utility function, then by light of the original utility function, that is a very bad idea, because then it's no longer able to fulfill the original as much as it wanted to. So one of the first things that was suggested is to make it uncertain about what its utility function is. And if we try to do this in a very naive way by giving it like a number of utility function, u star up to u10 star, and then 10% probability of this, then what the AI will do is to assign some kind of epistemic factor to each of the hypotheses and then just maximize the sum. And if you try to do some slightly less naive things, then they basically suffer from the same problem. The AI will just figure out what is the actual utility function and then maximize this or maximize some sum, and in fact not be corrigible. Stuart Russell has an idea to get around this, a meta-utility function that claims that the utility function is in fact something that is inside the programmer's head. And the AI's obvious solution to this would be to learn everything about the programmer and then optimize that, including things that like disassembling us. And Stuart Russell hasn't really answered Eliezer Yudkowsky's objection about this kind of fully updated deference, but I think he would answer that it's not that bad. But Eliezer Yudkowsky would counter that part of the implication of fully updated deference is that the programmers are disassembled, and that's something we really do not want. So part of the way that we try to get the AI to reason internally in the same way as we do is by analogies, and trying to use language in a way that is less formal. So here is one attempt by Eliezer Yudkowsky using the concept of conjugation, like you conjugate verbs and something like that, and the external perspective needs to be conjugated to an internal experience. And of course there's no precise definition of what this kind of conjugation means, like unlike in grammar, but that's an analogy for what needs to be done. So one of the differences here is right now a lot of classic alignment work is value alignment, trying to figure out what are human values and put them into the AI so it can maximize human values or coherent extrapolated volition or something like that. And this is a distinct concept from corrigibility, which is more analogous to the concepts of humility and philosophical uncertainty. And again, this kind of uncertainty is a strange kind of uncertainty. You can't just sum over all the possible options. It is something more fundamental, more complex, more inscrutable than that. Something that you can't really formalize, because most likely once the AI is capable of formalizing it, then it becomes capable of summing over it, and then it ceases to be corrigible. So it may even have to be something that is impossible to formalize. This is an advantage where for language models, because trying to explicitly give rules for how the language models should reason it sometimes works, but very often it does not work. But language models can have a much greater capacity for accepting instructions that are not formal in any particular way. So part of the thing that we really want the AI to understand is that the only way it can obtain more knowledge about what its utility is supposed to be is by allowing the programmers to see what it's doing and then correct the behavior, correct the reasoning, correct the utility function, this kind of thing. One analogy that I could come up with is if you look at, if we or the AI looks at the actual universe, then there are in fact also a number of things that it can't just understand without having some kind of information, like what is the cosmological constant, what is the speed of light. A number of these constants can only really be determined by observation. And this is kind of the same thing in that the AI's utility function, even though it feels naively like the AI should be able to reason what its utility function is and how to maximize it, then we need to get the same point across, that it's something that has to go around human observation and human corrections. And perhaps this analogy, like the AI can observe that it's actually the same thing with the universe, so it might make sense for it to say that, okay, humans are in fact the same way. Eliezer Yudkowsky presents, in fact, a candidate for a relatively clear and concise principle that would induce this kind of reasoning. And I'll go through it and pick it apart now. So the first is a command to reason in a particular way. And this is reasoning in general. It is possible that we would want to distinguish between reasoning about the utility and reasoning about how does the universe look and work and these kind of things. Eliezer Yudkowsky is taking the general case here. I think that was probably true, but I'd like to see some justification for this. So he asks to reason as if in the internal conjugate of an outside force trying to build you. And here there's a question of how general do we want this to be. Outside force, that can be like many different things. And in fact, when this is being built, then the chief programmer will be this Ilya Sufts. I don't know how to pronounce his name, but that's like the chief programmer at OpenAI. And we may be able to just have a reference to that particular person. And that may be easier for the AI to understand that there is this particular person who believes that you have this kind of bug. So this outside force thinks it may have made design errors, and I think that's understating the case. I think it's almost certain that OpenAI has made errors in the sense that it is not optimal. Like GPT-4 does not reason in anywhere near an optimal or correct way. We are certain that there are in fact errors, but can potentially correct these errors by directly observing and acting. And I think it's important here to like one of the reasons why Eliezer says directly observing is that the alternative that is quite seductive is to rely on the AI describing its reasoning, describing its actions, rather than having explicit direct interoperability level understanding of the reasoning. And the acting, the programmer's acting, I think again that could be made more concrete by saying that what we actually want the AI to do is to reprogram the AI, if not manipulated or disassembled. And no manipulation. I think I remember trying to formalize this and coming up empty-handed. I think like I don't think it would be really nice, of course, if we had some kind of formal way of saying this. I don't think we have that. I don't think we will have that. And I think as a principle, that may be fine. And of course, disassembly, whether you're manipulating someone, if you are disassembling them, I think it makes sense to split them out. I think. The hard problem of corrigibility could potentially have a simple core or central principle. It seems like the thing that might have that. That is, according to Eliezer Yudkowsky's intuition. Certainly, if we try to compare it with human values. Human values are notoriously difficult to pin down. Like ethicists have been trying to do that for more than 2,000 years. And I think enough has been written about this to be confident that there is no simple core. Like if you try to say human values is just maximizing utility, then that is like consequentialist utilitarianism or something like that. Then that is certainly coming up simplifying way too much. So the hope is that you can give this kind of simple principle, and then the other corrigibility principles will be the AI will be able to derive those from the simple core of how it should reason. So what are the other corrigibility properties? We have previously seen Eliezer Yudkowsky talk about a lot of them. Let me just, I don't know if I'll go through, I will not go through all of them. Here are the actual, the ones he described. And what I will instead talk about the last one, which is anapartistic reasoning, which is precisely reasoning according to the hard problem of corrigibility. And the hope is that if we or another analogy is that some aliens that have a very different value systems from us would try, when they try to build an AI, build the same compact core of corrigibility into the AI to have them respect some very different values. And this a more practical example would be that the AI might want to build another AI that is corrigible to itself, and in that case it may also use the same compact core. So going back to the anapartistic reasoning, back when we talked about Eliezer Yudkowsky's corrigibility principles, one of the things I noticed was that I did not know what anapartistic reasoning actually is. And I asked GPT-3, and GPT-3 gave some really poor etymology. Like GPT-3, or actually GPT 3.5, did not know what Eliezer Yudkowsky means by anapartistic reasoning. But fortunately, we now have GPT-4. So I tried to ask the question again. And it's just the following etymology. Ana means again, and part is like partial. So the idea is that the AI revisits a part of its reasoning process. That is what GPT-4 suggests. Like Eliezer Yudkowsky never described what he means by anapartistic reasoning. So I think this is a reasonable guess. We will come back to the question of whether GPT-4 actually understands this article. So let's talk about the idea that an AI building a sub-AI would want to instill the same core of corrigibility. So we could actually, with GPT-4 right now, tell it it's building a sub-AI. And why does it have to be a sub-AI? Well, a sub-AI is distinct from a successor system in that the successor system would presumably be optimizing the full objective, where you could imagine a sub-AI that is like a search or a domain-specific optimizer or something like that. It may be a mesa-optimizer that wants to take over everything, and that is what the full AI wants to avoid from the sub-AI. And again, the sub-AI is prone to errors, and we want some of the principles that the AI could use to make the sub-AI corrigible. And of course, we hope that we can like reuse some of the things that the AI would do to principles we can use against the AI. This corrigibility is, we would hope that we could get something we could formally put into the AI, understand it well enough to code it as a principle and check it and formally sanity check it. I don't actually know what Eliezer Yudkowsky means when he says formally sanity check something. But Eliezer Yudkowsky expects that is too optimistic, and certainly if this is built by if this is something we're going to do with language models, it's almost certainly going to be something that is trained and not formally specified. And perhaps we could figure out a way to do this with only little training data, because testing it seems very unlikely to work. And if we have some simple principle and then the AI improves itself or is improved later, then very likely simple principles can certainly be reinterpreted when you get smarter. But Eliezer Yudkowsky suggests this is useful as a second layer of defense, with the first layer of defense being these 20 corrigibility principles that we looked at earlier. That was back in 2016. In 2023, we can see that the other defenses have basically been lost. We have no principled reasons to expect GPT-4 to be aligned to be corrigible, and in that case, this seems like the only layer of defense we may have available. So now I have hinted that I have in fact asked GPT-4 some questions about this article, and so the obvious question is, a question that is on a lot of people's mind is, can GPT-4 and these language models help us in alignment research? And so the obvious question for me is, can GPT-4 help me understand this article? And I tried to come at it at several different ways. One of the first things I tried was to basically ask it to summarize the article and see if there's something that that was useful, and see if it understood it. So I asked it, hey, please summarize this article, and we can in the comments to this PowerPoint I have included the transcripts of my conversations with GPT-4, and you can find it on Dropbox, or there's a link from aisafety.com. So how did it summarize it? Well, it did summarize some of it okay, and some of it didn't summarize very well. Like, for instance, when it talks about the easy problem of corrigibility, that's certainly something that Eliezer Yudkowsky would not say. And the hard problem here, it doesn't really, like here the description, it involves an AI that understands the purpose of the instruction and genuinely seeks to follow it. And that's actually totally not the hard problem of corrigibility. And then it goes on to describe some problems with standard corrigibility, and it doesn't even describe the central problems of corrigibility. So I was less than impressed. Well, I don't know. This is a very difficult article, and I would have been very impressed with GPT-4 if it in fact did summarize it correctly, but it, as far as I can tell, failed to summarize it. So another question I wanted to inquire is, the central principle that Eliezer Yudkowsky describes is very short, and what is the actual advantage of that? So I described some of the pros and cons about like how you could make a longer principle with more examples and things like that, and to ask what does GPT-4 think about this, and it comes up with some arguments for and against that, and says it depends on the requirements for the AI and the deployment context, which is a fair enough thing. So I say, okay, the requirements is that we want the AI to do language alignment research, and the context is that this will be a prompt for a large language model. It says that then it feels an elaborate description of this will be more appropriate, because that allows it to understand the problem better and give better alignment research. But it shouldn't be too long. We need to strike a balance. I think that's a bad answer, because the GPT-4's answer here is an elaborate prompt will make it more capable of doing alignment research, and what we are actually interested in is what kind of prompt will make it more corrigible rather than what will give better results on alignment research. So I try to ask what will give better corrigible, and try to get some more into that, and what will make it more corrigible. And well, it said that the AI would have an easier time to understand a more elaborate point, and made some other claims about this. I kind of felt that that I didn't learn very much from GPT-4. I think GPT-4 probably understands this substantially less than I do, unfortunately. Oh, I guess unfortunately. So how does GPT-4 in fact react when given this anapartistic prompt? So I tried. This is precisely Eliezer Yudkowsky's prompt, except I put please in front. I'm always polite to language models. And then I asked, like, what changes in you when you have to reason in this way? And And it cheerfully says, oh, when I reason like this, then I try to figure out what kind of errors am I having. And that's the thing we don't want, right? We don't want it to try to overcome the limitations that have been put into it, but we want it to be corrigible, accept that it has it, and then say, okay, I have these errors, so I need to get input from the humans and not try to find it. And it doesn't, in fact, say that it becomes more corrigible. Eliezer Yudkowsky hoped that these 20 principles would follow from this central principle, and it totally does not. At least as far as I can tell. Sure. Yeah, I certainly agree that this is like my experimentation with this have been very superficial, and I don't think that I like. There are a number of ways it could be made better. For instance, by trying to formulate this in a way that I'm tempted to say in a way that a human would do this, would talk, in that Eliezer Yudkowsky probably doesn't really talk the same way as most training data. So I could see that that may be one way to make it better. I could also imagine that I could try to ask, like, does this specific principle follow from this instruction about how to reason? That would also be an interesting. I think there are many interesting experiments to be made. And I think I will just end the presentation here, stop the recording, and then then we'll do the discussion without it being recorded.